which messed up a little bit last week getting it to record. And I need to go back and show you how to load a data set into the database on the computer, but it's fairly easy. You do it in ARC catalog. You just right click on the data on the database and say import. But I'm still going to make another copy. Sorry, another copy, because the first half of last week's lecture didn't get recorded. So I'm going to go back and make that up. In fact, if you look at here's the Blackboard for this class. Web map. And then course materials. I've added some things here. That's another reason why I'm going here. Okay. So I've added all this text. I modified this query so that it actually works, because remember, it didn't work right off. All I had to do was add the SRID, the spatial reference ID, into that query, and it worked. All right. I've uploaded or I put the link for the first video second part, and I'll post the first part after I do that, probably after class today. And this all pertains to today, what we're going to do today. And before I get started on today, I'll go over scheduling just a little bit. Well over half the class will be gone next week, the students. And so what we're going to do, I'll call on Tuesday. I'll call down to the coast, but we won't present any material, because most people won't be here. And so if there's any questions that anybody wants to have answered, I'll be in the room for the 2 hours, or the hour and a half to hour and 40 minutes that the class runs. Okay? So if you want to help on any of the labs or on a final project, you can come to that class and get answers to questions. If you feel good about anything, and you know, I think somebody already said, well, you know, it'd be nice to get an extra day during the Thanksgiving break. That's fine too. So no formal class meeting next week. Basically, what's happening is there's a big, well, not a big, but it's the regional conference for the graduate students that they all go to. So that's where they'll all be. So most people will be absent. So we won't present any new material a week from today. All right. So on to today's topic. So if you recall, last time we met, we built, or we didn't build it, but I showed you that I'd created a GeoDatabase. And we put some data in the GeoDatabase. We put the cemetery data inside the GeoDatabase. I wonder what's going on here. Let me just refresh it and see if that'll solve the issue. Huh. Refresh. Just a second. See, no. Yeah. All right. It's interesting. I'm going to go ahead and download the example for today, because if that works, then that's going to be good enough for now. Hopefully that'll work. Show in folder. Open with. So this should pop up Mississippi and put a layer that represents all the counties on top. Okay, that works. Not exactly sure why we're having an issue getting into the GeoDatabase. Okay, but we're not going to work on that right now. Maybe there's just something that needs to be restarted on the server end. I'll check into that. Anyway, I was going to review the fact that we put some data into the GeoDatabase. Obviously, we can't see it right now, but it still exists in the GeoDatabase because we can see it here. It still exists in the GeoDatabase. And so what we're going to do today is talk about how this happened. Basically, the way that this happened is that there's now a service running on the server that is waiting for requests. It's waiting for an SQL query, and it returns GeoJSON. Okay. We'll test that. We'll show that. And it can operate with any data that's currently in the database. This service doesn't allow you to put new data in it, but it allows you to get some GeoJSON out of it for any of the features. What do we mean by that? Well, we've loaded counties, watersheds, cemeteries, dams. I think a few people have uploaded their own data. You saw before I refreshed that page, there was a couple more data. And eventually, when I figure out what's going on with the server there, you'll be able to put your own data on and create this. So this is a way to bypass the other technologies that we've learned about in this class, which were map server-based tools, either ArcGIS map server or GeoServer. We're not using any of those. Here, we're just asking the service for features, and the features come back, and we use the browser to symbolize them. In this case, I just said use the default symbolization, which is that blue. But if you remember, we could change that if we wanted to. All right. So if you look back at the Blackboard course material here, you can see that I've written up a small. This could be called a really small, simple API document. It's an application programming interface. It's very simple. This is the endpoint to the web service that I have running. So that's at 10.64.78.100:9000. So it's running on port 9000, and it's a simple service. In fact, if I copy that and I put it up here, Control V, it gives me a little message and tells me that Q, S, and F are all required. And that's just the message that success was false. So we can see that service is running, and it returns a cryptic, but still a valid message. For those of you who are curious, this isn't some big open source piece of software that's running. I wrote the software. It's probably 15 lines of code that's doing this. So it's just a little Python script that's running on the server that's waiting for requests. Right now, what it's done is said, okay, well, you didn't specify a query. I'm expecting you to give me a query. Okay. And I want a few other parameters. Let's look at the API document again and see what those other parameters are. Okay, it looks like the other parameters are S, which is a shape field name, and F, which is the field names that you want to return separated by a comma. I did specify that there must be at least 2. So my tool requires you to specify that you want to get back at least 2 fields. If you don't specify any fields you want to get back, that would be ridiculous. I suppose it should probably work with a single field, but it doesn't. I didn't write it that way. So you have to specify at least 2 of the fields. Now, where do you get the field names? You get them from the data. You should know, because you put the data there, what the field names are. So there's no method for getting that. All right. So let's build out a simple query. Okay. I know it's been a little while since we built our own queries or talked about that. But to build your own query, I'm talking about a URL string query. We need a question mark. Okay. And in order to specify one of these parameters, we say the parameter name equals, and then we type the value. So in our case, we say Q. Now don't worry, in the end, when we get done with this, we're not going to have to type in any of this information. Leaflet's going to do that for us. Leaflet's going to form the query string for us, okay? But we're going to practice, we're going to figure out what's going on by doing it this way. So we're going to put in a simple query. This would be the query that you created in ArcGIS. Okay, a very simple one would be select star from dams. Okay, what is that going to do? It's going to select all the fields from the dams folder. I mean, from the dams table. Okay. All right. So that's that one. I'm going to add one little twist just so this won't take a long time to run. I'm going to say limit. I'm going to say 20. What that does in SQL, you don't need to know this, but this is helpful for debugging purposes. When I add limit, the limit keyword onto the end of the query, it's only going to return up to that many records. If there are only 5 records to return, it'll only return 5 records. But if there's 2,000 records to return, and I think there were over 2,000 dams, it's still only going to return 20. So just for testing purposes to see what's going on here, I'm going to specify limit 20. And then the next thing that I need to do is say, and use the and sign and say S equals the name of the shape field. Most of the time for us, it's going to be shape because we're uploading data using ArcGIS. But somehow if we got additional data into our GeoDatabase from a different source, it could have a different name, like geom, I told you, is the default shape field name. Okay, and then finally, the last parameter that we need to feed it is the list of field names. And for dams, I believe area is one, and I believe, I think there's a name field. Hopefully, if there's not a name field, it'll return an error. I know there's a field called dam_ID, but we'll try this. Okay, so now I press enter. And, oh, sorry. I forgot to say and F equals, there we go. Then I press enter, now it goes to work. It's working on the server. It's attempting to answer my question. It's sent it off into the other room, and it comes back with an error. Okay, there must not be a name field, but I know there's a field called dam ID. So that should work. I don't know why that doesn't work. Field. Maybe there's not a field called area. I spell perimeter, is that right? Perim, like that. It must be called like area underscore or area something, because So if I'm messing up on the field names, I can't actually see the names of the fields. Here I know I can solve this. I thought I would have access in ArcGIS to see what the field names were, but for some reason that's not working. So what I'll do is I'll remote desktop in and see what the field names are so we can get a valid field name. Administrator. Been too fast. Okay. Well, perimeter is on there. An area is as well. All right. Well, I'm a little. I'm wondering why it's not working right now, because it is working here. In fact, if I let's look here. If I open up this in Notepad, I change this to. So this is select star from counties, and F equals CO name and CO seat. That's equals shape. Let's try to change this. Dams. Perimeter, dam ID. Oh, dams ID. Okay. I'm making some error that I just can't see because the service is working when we let Leaflet build the query string for us. Okay, it's just I'm making some error in my my typing up of the query string. So I'm trying to type the query string, and I can't figure out what my error is. But like I said, we don't actually have to do this ourselves. We can let. Okay, I don't know what happened, but now it all of a sudden decided to work. Thank goodness that we don't actually have to type in the query string. I finally got it working there for dams. So you can see the JSON that gets returned using this query string up there. Okay, so I said, select, and it doesn't, URLs can't have spaces, so it was corrected. So this is select space star space from space dams space limit equals. This is the code for equals, and then this says a 20, and then the other parameter was the name of the shape field. it needs to know what the shape field is in order to build the output, the GeoJSON field, the GeoJSON data. So you have to feed it the name of the shape field, and then you feed it the name of the fields that you want in the result. Now, one of the things that's curious is, and this has to do with me building a rather simple service, is that if you look under the properties, instead of the real field names, there's a field called F1 and a field called F2. Well, F1 is DAMS ID and F2 is perimeter. You just have to remember those. And if I added another one in here called area and refreshed it, now F3 would be area, F2 would be called perimeter, and F1 is DAMS ID. So if you're trying to get these later when you do a pop-up or something, or you're trying to symbolize using one of these values, you just have to know that they're called F1, F2, F3 after they get back from the server. I think percentage 20 is a space. Percentage 20 is space. Percentage 20 is space. Oh, I don't have any, sorry, I didn't have any equal signs in there. Select star from DAMS. So, but the nice thing is here is it really doesn't matter what percent 20 means. It's going to handle that, but yes, percent 20 is equal to space. You don't have to build the query string yourself, okay? So what happens is, if we look at the code I've created here, is that we're gonna execute our old friend that we've used before called l.esri.request. And l.esri.request takes a URL and parameters. And the code in this function that already exists, that code is going to take care of putting the percent 20s in here and any other invalid URL strings it will put in there and change them and code them to what they need to be. So we don't actually ever have to type our URL. So that's what this line of code does. You say, these are going to be my parameters. You need to give it an object. In our case, we need 3 parameters, Q, S, and F. Why do we need those 3 parameters? Because that's the way I wrote my particular service. You could write a different service, but that's the way I wrote it. It's not in some standard format or anything. But you'll notice that this happens a lot. People will create a web service, and there aren't a whole lot of standards for that. Query Q is a pretty widely adopted standard for retrieving for sending a query across, okay? But as an app, I just kept it simple. I could have called it shape field name, but that would be very long. I could have called it other fields that you want, but that's too long. So I just called it QS and app. And here, I specified the URL, I gave it the parameters, and then what's going to happen is if it gets an error, like I was getting an error the first time, maybe we can make it force an error. If we said something like select, if we just left out the star, it's going to get an error. Now if I run, let me open up the console first. So now if I rerun this, I'm going to get an error in there. Could not parse response as JSON. Okay, so it's basically telling us that it couldn't get the response wasn't valid data. So now I refresh that. now I'm getting valid JSON. I also know I'm getting valid JSON because these points showed up. And as I change the query, like I could change the query to say limit 1,000. Now I can refresh. I'm going to get back 1,000 points. It's going to take a little while longer for them to come back, but they all come back. I can access the actual GIS data, and this is the response that came back. So this here is the same thing as this. See that? All this text is the same thing as right here. I can see the features that came back, and I can see their geometry, which is just a point, and I can also see their properties. In our case, there's just going to be an F1 and an F2, and that's it, unless I specify an additional field. So yeah, there has to be, remember, there has to be at least 2 fields. So in this case, I believe one of these is perimeter, and one of them is that DAM ID, DAM's ID. Okay. So we can change this back and say counties, and change this back, and I think we had CO name and CO seats, like that. I'll know if it was right because it'll come back. Yep. All right. So now if I expand this, I get my results back as properties. F1 is the county name, and F2 is the county seat. The county seat for Tishomingo County, I guess, is Iuka. I don't know if I'm pronouncing that right. All right, so why is this powerful? Well, we already demonstrated a little bit that that GeoDatabases like Postgres and even ArcSDE and other spatial databases can do some GIS processing on the back end. They can do some GIS processing on their side. So we can specify a query that does some GIS processing, and we can see that result in here. So let me show that real quick. So that's why I fixed that, this quote right, or sorry, this query right here. What if I send this query through? I'm only going to get the dams that are within a certain area of that that point. So Control V. Oops. Now let's put all this in the inside the quotes. So now it's going to say select dams from, select star from dams where they're within that query. Now I have to change this to make sure that it's going to get back some of the dams data. So these have to be valid fields, unfortunately. That should work. Let's see what happens. And you can see that we've returned dams that are within that area. So let's take this a step further. So instead of just returning the dams in this area, let's let the user click on the map and only return the dams that are within the user clicked area. Does that make sense? So we could do something like that. So what we could do here is, instead of having, right now, by the way, right now, when does this code get executed? Right when the page gets refreshed. What do we need to do to make sure this code gets executed not when the page loads, but when the user clicks? What do we need to do? Yeah, make an event. This is borrowed from our previous class, so we actually already have our event. All we need to do now is move that event down to this port. I mean, sorry, move the code down into the event. So we could take all of this data, and all this, not data, all that code, and move it down into this event. So now it's only going to run when the user clicks. I'm just going to indent this. Indenting is not necessary. I just want to make sure all the code lines up there. Now all this code is not going to run until I click. So I'm going to click on the map, and it shows up. Refresh. Now it just keeps adding it over and over. That's not good, but it's still working. Okay. All right, let's modify this code so that these values right here come from the click. You should be able to do that pretty easily. These values are latitude and longitude. We already know that we're going to get latitude and longitude from our click by default. So we don't have to transform these into Web Mercator or anything. We're going to get a lat long. In fact, if we go back up here, we can see, this is kind of a refresher at this point, but here's our latitude and longitude, 3289. Now, I said that PostGIS does have the ability to do a transform. So if our data was in a different projection, we could do that transformation as part of our query. But we don't have to do it as part of our query, thankfully. So we can just say e.latlong.lat. So it looks like this one's going to be the lat. We can do something like this. E.latlong.lat, E.latlong.lat, and then this will be the same. We have to change a few things. First off, this is a string, okay? Right here. This is a string, so if we just run it like this, it's actually going to send this as part of the query, these words, e.latlong.long and e.latlong.lat. That's not going to work. We need to actually send the value, the latitude value and the longitude value, or the latitude value and the longitude value. We need to send those values, not the text, okay? So how can we solve this problem? Well, one thing we can do is, see, these are quotes, right? So what we could do is change it so that our text looked like this. All right, now that, I added an extra one. Oh, I still need that one. Something like that. Okay, that's what we need. All right. What does this work? Well, what we're doing is saying, okay, our query is going to be all of this stuff on this side, plus then add the value of this in there. Now, who's taken some other programming languages, a course in a different programming language like C or even VB? What happens if you added a string to a number in most programming languages? You get an error, yep. Okay, JavaScript's not like that. It'll try to base it in computer programming lingo. It will cast. It'll try to figure out which parameter you want to cast to the other parameter. And so if there are any strings, it'll cast everything into strings, change everything into strings. So what this is going to do is give you all this text up to this point, plus it's going to say, okay, here's the value that you want to turn into it. Instead of giving you an error, it's going to turn that into a string, and then say plus, and then it's going to add, remember we had a space before, and then it's going to give you the latitude plus, and then the rest of the string up to this point. So you're just basically creating a sandwich where this is the first piece of bread, that's the second piece of bread, and these are the ingredients. And the plus signs are the things to add up your ingredients. So in most programming languages, a plus sign, when we're talking about strings, does concatenation. So that's what's going on here. You concatenated this string, this thing that got turned into a string, this string, and this string. We've glued them together, concatenated them. So now our query will look correct. It'll have these words, it'll say plus, and then it'll change that number to a string, space, it'll change this number to a string, and then it'll add that onto the end. So I'm going to go ahead and save this and refresh the page. Remember, nothing will happen at the beginning. I must have screwed up somewhere. Let's see, line 57, yep. Okay, where did I screw up? Oh, what's this? See this little, what do you call that? Parenthesis? That should go inside the quotes. It's part of the query, not part of the latitude. So that's where I messed up. So refresh it. Now when I click anywhere, see how it gave me all of the dams within, it's 0.2 degrees of that click. And as I continue to click in other places, it continues to give me all the dams within 0.2 degrees. It's not a very good method, or not a very good buffer to use, but it's still working to give me all those points. See how everywhere I click, I get the dams that are within that area. I could do something like add up all of the area or perimeter values and report that. And I could do all sorts of different things with this ability, but I basically created a method for doing some GIS processing on the web. On the server. So the overlay gets done on the server. The overlay between our buffer point and the set of points. So that's how I modified that. Just to give you an idea of what's going on here, I'm going to take this and console log it. I'm going to refresh the page again. So I didn't save it. I'm like, I didn't log it. Okay. See, this is the query that gets sent off to the server. Select star from dams where SC within shape, SC buffer, blah blah blah, and these are the values that got sent. This is the click, where the click happened, and so all that, plus e dot long and plus e dot whatever dot lat, that got turned into that value. Okay. So we can dynamically change something. We could also dynamically allow the user to change the buffer size. Okay. So if we just went in here and change this value to something else like 4, now if I refresh the page, click it, I get back a lot more points. It doesn't look like, the point I clicked is right here, it doesn't look like it's in the middle, but remember these symbols are tall, and the bottom of the symbol is where, so really it's like this. It really is in the middle of the click. It just doesn't look that way because of the fact that it's the symbols are so tall. If we made the symbols points, it would look like they were right in the middle. Another thing that we could do is actually, if we wanted to, add a circle symbol to show that that area. I wonder if this would work. So, just really quickly, look at this part of the equation. I mean, of the. Do you see this query? If I run just this query, oh, that's really, really small. But if I run just this part of the query in Postgres, oh, yeah, I have to say select. Select star from, yeah. So here I've created a little query that says select everything from this. And it returns st buffer. It returns that st buffer. Oh, what if I say yeah. All right, this is really, really small. I'll blow it up here in a second. As all right, so what I've done here, it's hard to see, but I've created a little query that just basically asks Postgres to create a circle, and I've created 2 dummy fields in the return value. So it's buffered, and then it creates a circle right here, and then it adds 2 dummy return values called ID and area. And I'm going to put this dummy query in there just to give you an idea that you could really do anything that Postgres would let you do that returned a field, and put that in the query. So here I've got, I'm not even sure this will work, but here's my new data. I'm gonna put this part back in so that it's getting the point where it's clicked. And the 2 field names are called ID and area. So I need to change these to ID. Is the area capital or not? Nope. ID is capitalized. I'm going to make ID lowercase just in case it throws it off. Make it lowercase over here. I'm going to return, refresh. Now when I click, S select. So now when I click, I'm getting those buffered circles. So the difference here is this buffer circle isn't being created on the client. It's created on the server. I'm asking Postgres to buffer the point. I'm passing the point up along with the query that tells it, the query tells it to buffer that point. And then it buffers the point and returns the geometry back to the client, and it gets symbolized. So this simply draws these circles on the screen, but the the processing got done on the server instead of on the client. Now here, there's no real reason to ever do this. You would really want the server to do that processing. You want the client to do that processing for such a simple task. But what I'm trying to show you is if you really dive deep and get involved into what SQL and spatial SQL could do, you can basically create anything on there. And not necessarily even that deep, but the service here can take any request to our GeoDatabase, any SQL request to our database. See that? Oh, it's not letting me click right on the guys. All right, now this isn't totally related to this slide, but are those perfect circles? Now, why aren't they perfect circles? Just so you know. I mean, just I'll give you a hint because this is good geography knowledge. Okay, I'm going to go down here. Look at that. Does that look a little bit more like a perfect circle? Yep. Right. Well, yeah, because of the projection, exactly. And so, what did we tell it to buffer? Here's our query. We told it to buffer, and we're using 4326. What's 4326? So we've got latitude and longitude values there. What's the value we're telling it to buffer? 0.02 in degrees. And remember, I said that's not ideal to use degrees, right? So we buffer that value, and we get a circle that is 0.2 degrees. So in other words, from right here to up here is 0.2 degrees. And from right here to right here is 0.02 degrees. And also right here to right here is 0.02, and so on. But we could create the click, yeah, and then yeah. Let's see if we can change this at all. So we've created this big click. This click, and we've created it using that geometry because that is the geometry. Then we could say, okay, we want to can I just add that one? Yeah. Yeah. Then we want to add another one in here called transform. So it's going to transform everything in that area, and it's going to transform it to 3857. Then it's going to buffer. Transform. Then it's going to buffer. And now, instead of using 0.2 as our buffer distance, because that wouldn't work, because 3857, remember what ID 3857 is? Web Mercator. So Web Mercator uses what units? Meters, exactly. So Web Mercator uses meters, So buffering 0.2 meters is going to make it a circle that's so small we can't even see it. So let's change this to an appropriate meter unit, maybe 20,000. Okay, it's going to create a big circle. And now the trouble is that when we get back our data, it's going to be in 3857. That's not going to do because Leaflet only wants GeoJSON in 4326. So we could then say, okay, change it back to 4326 like this. And we could go back over to here and do another ST transform. So now, we've done GIS operations in a few different software packages now. We did it in leaf.js. And so the way that we would read this now is from outside in, or sorry, from inside out. The first thing that we're doing is creating a new point from this text. Then we're transforming that point into Web Mercator. Then we're buffering it by 2,000 or 20,000. Then we're transferring it back into 4326 for display. Okay, I have no idea if this is going to work. Let me see. What we're going to do here is see what this says the issue might be. I wish this was bigger. Oh, that didn't take everything that we wanted. Oh. Okay, so what I'm going to do here is take this line of code and console log it so I can see what it actually says. Control C. I'm going to console log it, save. Oops. Now I'm going to rerun it. So here's our click, and here's what it actually looks like as a select statement, as an SQL query. And I'm going to put this in here. ST buffer. Oh, it's called something else now that it's not being buffered. No, the buffer's not the last step. There we go. That's the result. So the result is now called ST transform instead of ST buffer. So that's right here. Now when we click, we're going to get something that's a lot closer to a circle. Okay. See how it looks like a circle? Okay. And even when we go way up north, we click, we still get something that looks like a circle. All right. More about projections. This circle and the circle that's in Mississippi are the same size, right? On the map, they're the same size. What's the issue now? Yeah, so this circle, because it's the same size as the circle down here, it's actually circling a smaller area on the ground. But we said to go out 2,000 meters. So there's distortion in either way you do it. Okay. The way to get the best true circle would be to convert, like to take the clip, to convert it to a local projection that was very good, that had a small amount of distortion for that area, convert it into that projection, do the buffer, then convert it back into 4326. And it might look a little strange, but it's going to be the closest thing to a true circle for whatever area the user clicked on. It might look strange up in the northern area, might look strange, whatever. Okay, but it may be that you get to a job and your boss says, "Hey, okay, I want it to always be a circle." Well, it's probably your responsibility to tell them if it's always a circle, it's not always going to be right, especially on a web map. And then you could suggest a better way to end up doing it. Anyway, got off on a little bit of a tangent there, but this is always going to be a circle because it's always going to go out 2,000 units on the map, no matter what the distortion of the map is. So here, obviously, distortion changes as you leave the equator. Get more distortion up here, more distortion up here. The reason why the distortion occurs is because if I measure 2,000 units here and 2,000 units over there, I've gone over a lot more land. All right. Okay. So this is a rather simple web service that you all can implement if you want to utilize this in your final project. It would work. It's gonna be up there and work. Again, I'm sorry that USM dragged their feet so long. So this will only work on campus because this URL will only work on campus. If you ever find that this service is down, it's not working, let me know because it could just be that this service or the GeoDatabase is down, and it could just be because there was a electrical storm or something, the server got rebooted and something didn't start up right. Everything has to start up in the proper order for this to work. And so most of the time, this should run for a long time, but there was an electrical storm recently. Maybe that's why the GeoDatabase isn't being visible in ArcGIS. All right, any questions, anything else would you like me to demonstrate? If you could think of another GIS operation that you would like to perform doing a GeoDatabase, I can demonstrate a different operation. So we've done basically a small clip operation. You could do a spatial join. If you followed through the examples that were there. Let's see. This will only work with vector data. Although you can load raster data into a GeoDatabase, JSON doesn't support raster data. So JSON only supports vector. So you could, let's say, have a raster data set in your GeoDatabase, and then you could do an SQL query because there are SQL queries that'll do raster to vector conversion. So let's say you wanted the user to click on a certain point and return the data that was below it from a raster data set. You have to convert that to raster in order for it to be shown in a GeoJSON data set. All right.
Display raster in general.
Most of the time, if you just wanted to display raster, I would use a map service rather than I wouldn't use a client-side technology to display that. I think that eventually there will be tools, and there's starting to be tools that basically stream portions. So, like, depending on your zoom level, you understand the concept of a pyramid layer? Have you heard of a pyramid layer before? So a pyramid layer will return a sampled version of the final copy. So, like, as I zoom in, obviously with this, I'm getting a whole different data set, a whole different JPEG. But imagine if there was a raster data set here. And as I zoomed in, the server would hand me a more and more detailed image, but it would only need to hand me the extent. And so I would be guaranteed to only get an image that was 1 or 2 megabytes every time I zoomed in at the most. And that would still require a pretty fast internet connection to have a 1 or 2 meg data set come back every time, right? So if I'm zoomed way out and I had a high resolution satellite image right here, right? If I'm zoomed way out, it's only going to give me every 10,000th pixel or something. And I could then symbolize that however I wanted to. And then as I zoom in, I get it, you know, every 100th pixel and every 20 pixels. And if I zoom way in, it'll hand me every pixel. But I have to be zoomed way in for that to happen. And I could symbolize it. And that would be the equivalent of a GeoJSON layer, is a tool like that. And those are in the pipes. And some people have some like development versions of those that may make it into a class like this eventually. But what I would do for now is use a map service to handle raster data. So the disadvantage there is you can't symbolize it on the server. You can only symbolize that. You can't symbolize it on the client. You can only symbolize it on the server. So you set up your server, and if you need it symbolized in different ways, the only way around that is like in ArcGIS would be to have multiple layers for that raster. As you zoom in, perhaps you could change which layer gets shown, or in the open source world, you could have a different style descriptor, and then you could display different style descriptors as you zoomed in. So those are some options. But yeah, raster data is by nature usually larger than vector data, and so it's a little bit harder to work with on the client. But you know, as these technologies progress, I do think that's where it's going, is the ability to manipulate raster data. And actually, another thing that you could do is you could write a geoprocessing service. Like if you wanted to create some custom, like if somebody wanted to adjust, like if you wanted to find out the user clicks here, well, we've already done something like that, but this is another example. The user clicks here, and I want to find the viewshed for this area. You don't have to have the data on the client. You could write a geoprocessing tool to do that. You could also do that in SQL, but it'd be a very complicated SQL statement. But you write a geoprocessing server, they click it, it goes back out to the client. That's an example of something that would be hard. I mean, it goes back up to the server. That's an example of something that would be hard to replicate all that information on the client anyway. I mean, that's a pretty complicated algorithm. The viewshed algorithm is what I'm talking about. So, yeah. So it's always a question of what do I want to do on the web, and what can I get done on the client? I want to do as much as I can in the client, but only if it's faster to do on the client. Because if I can do it on the client, I don't have to go back to the server. I don't have to bog down my server, and I don't have to depend on that connection even being good or existing. However, if it's a unique GIS operation that can only be done on the client, on the server, or if it takes a really long time to process, I have to do it on the server, or I should do it on the server. Okay. And there's several examples of stuff we did in Leaflet where, if you remember, in turf.js, you remember I said, hey, if this takes a really long time, this is a candidate for something that you would do on the server instead of on the client. Okay. So always test out how long it takes on both. Not always, but test out how long it takes on both ends. and you can see. All right. Any other questions? So no formal class meeting on Tuesday, and then obviously we're not meeting on Thanksgiving. I know y'all are bummed out. We're not meeting on Thanksgiving. Just kidding. I won't even be here. I'll be in Nashville. The in-laws. All right. I'm going to figure out, because I still have, so what your assignment is still the same. So your assignment is to load a data set into this database and then consume it on the web and allow the user to change just something in your query that modifies it slightly. It could just be on and off, this or that. It could be a really simple query, or it could do some GIS operation. That's the assignment. So I need to go back and figure out why that doesn't show up. Because you need to be able to do that. Anybody have any question about the assignment there? We do, yeah. So in this class we still have a week before finals, because this is a day class. So the other class that lots of you are in is a night class, and that final is always on the last day of class for a night class. But for a day class, there's an actual final exam, and it's on the syllabus. Let me look here real quick because I got it pulled up. I wrote it down. Course materials. No, that's under syllabus. So yeah, let's look at this real quick. Oh, there it is. So we still have these weeks, and we're not going to need. This class has a lot less people in it. So these course presentations are going to. So this is the class that I'm saying we're going to dispense with, because I don't want to do the course review when nobody's here. And so we're not going to need a whole week to do this. So the graduate students are going to give a little presentation, and there's only 3 or 4 of them in here. So this won't even take a whole period. We could probably only have one more class period time and be able to do both the course presentations and the course review. Okay. The final exam is until Tuesday, December 8th at 1:30. So this is a day class, so it has a formal time. That's the time that's been given to me by the registrar to hold the final exam. Does anybody have a problem with that time period? Does that answer your question? Okay, so no formal class next week. We have another week after Thanksgiving to talk, and I'll send out some more details on that week sometime, and then we'll meet on December 8th for the final exam. It's a Tuesday, and it's just a half an hour later than the regular class time. I don't picture it going too long. All right, Heather, are you down on the coast today?
No, she's not here.
Okay. All right. I was going to. I'll email Heather. So the coast to be at the same time. The exam will be at the same time, but you won't have to come up here. We'll get hopefully Heather, but definitely have somebody there to proctor the exam. All right. Any other questions? I'll go ahead and upload everything and redo the first part of the lecture. and you should be able to do that. Okay. I have to visit the restroom real quick. I'll be right back.
Are you going to practice, or are you going to do the day before a run? Practicing next stages. Just recite the presentations.
I'll be driving. I will not be here. You have to get like to speak to me. Yeah. Yeah, there's a few people and I like the GeoDatabases drinks. Which I feel like is efficient. Right. Well, if you say I might be.
What I'm doing.
Sorry, I didn't go to the bathroom because he had to tell me something, but I wanted to get that other thing done and not make you wait here real quick. Let me do that. Okay. Where'd it go? Did I? Oh, let me